So today I just wanted to go through a couple proofs for formulas you may have seen before. This might be relevant for you if you're a GCSE student or just someone who's interested in maths and has never seen this before. So to start off with, we'll go through the sum of the interior angles. You probably have seen this formula before, and it states that if we have an n-sided shape, we minus 2 of it and multiply it by 180, we'll get the sum of all the interior angles of that shape. So to start this proof, let's say we just use a simple shape, a regular hexagon that has 6 sides. Now, if we follow the formula, we're going to have 6 minus 2 in brackets multiplied by 180 degrees, which is just 4 multiplied by 180, which just gives us 720 degrees. So each one of these angles will add up, all of them, no matter what size they are, no matter what the shape looks like, it will always have to add up to 720 degrees for it to be a 6-sided shape. Now, to actually prove this, let's say with this shape, we draw lines from one of our vertexes, so any one of the vertexes, one of the points, corners of the shape, and we start drawing lines to the other points in the shape. You will see that we start to begin to make some triangles in this shape. You have one triangle there, 2, 3, and 4. And since we know that all the angles within a triangle have to add up to 180, 4 multiplied by 180 will give us the sum of the interior angles of this shape. Now, you might be wondering, oh, why don't we just, draw triangles from the center of the circle? Why can't we just do this? Because that way, we'll have 6 triangles, they're all equal. Why can't we use this to figure out the sum of the interior angles? Now, the only problem with doing it this way is that although we do get the sum of all the interior angles as we want, as you can see, all of them exist, we also get, in addition, the angles that are within the center of the circle. Since the 180 degrees is this one plus this one plus this one, we get an additional 360 degrees that we do not want. And if we go back to our other triangle, if we draw on every single angle that exists within these triangles, there's one here, one there, another there, another there, another there. And it will build every single angle that belongs along the outside of our shape, which gives us the interior angles. And that's why this formula states what it states. Since we have any sided shape, we can even do a pentagon, for example. If I can draw one. No, this would... There we are. If we draw from one of the vertexes how many triangles we can make by going to the other vertexes, you'll see with 5, we end up with 3. With 6, we end up with 4. With 7, we'll end up with 5. And that's why we always minus 2 of the sides. And that's the proof for the sum of the interior angles. The next proof I wanted to go through was the sum of the exterior angle proof. So this states that the sum of all the exterior angles always will add up to 360 degrees. Now, you might be wondering why this is the case, but we'll take, for example, just one of our sides of the shape where a vertex joins together. Let's say our shape has n sides, so this is our nth vertex, if you'd like to think of it like that. If we have n vertexes, right, our exterior angle is always complementary with one of our interior angles. So what I mean by that is if we have y plus x, if each y was every single one of our interior angles and x being the exterior, they always have to add up to 180 degrees. That's a must because it's a straight line. And since we have n lots of these straight lines or vertexes, as you'd like to think, the sum of our exterior angles is actually going to be 180 degrees, so 180 multiplied by our n, because we have n lots of these happening, or n lots of pairs, you'd like to say. But we are looking just for the exterior angle. So we actually have to minus the sum of all the interior angles that we have. And using the formula that we've just generated before, we can do minusing the sum of our interior angles is going to be 180, so the same formula multiplied by n minus 2. And if we expand this, so the sum of our exterior angles is going to be 180n minus 180n, and then 108 minus 180 times by minus 2 is plus 360. And as you can see, our 180 ends will both cancel out with each other. So the sum of the exterior angles will always be 360 degrees. And that being the case, that means if you'd like to find any exterior angle of any shape, all you have to do is grab the 360 and divide it by as many sides as there are, because every single interior angle will always have an exterior angle. So if there's 6 interior angles, there will be 6 exterior angles. And that will just be, for example, for a hexagon, 6 sides, 360 divided by 6, which is just 60 degrees. And that's the proof for the sum of the exterior angles. And the last proof I wanted to go through was the exterior angle theorem, which is slightly different to the sum of them. And this states that if you have any two sides in a triangle or any shape, these two angles should add up to make this angle here. And the reason, the proof for this is, for example, let's take this triangle here. You have all of them, or all the angles within this triangle, so x plus y plus 20 equaling 180 degrees. And we also have a straight line, which is these two together. And if we know straight lines are always adding up to 180 degrees, or they always are 180 degrees. So we have y plus 3x plus 2 is equal to 180. Now, since we have both of these equaling 180, what we can actually do is set this equal to this. That way, because they both have to have the same value, then they both have to be equal to each other. So x plus y plus 20 is equal to y plus 3x plus 2. So if we minus y from both sides, our y's will both just cancel. Minus x from both sides, you'll get 2x on one side. And if we minus 2 at the same time, we'll get 18. So then 18 is equal to 2x. So then our x, if we divide by 2 on both sides, will just be 9. And that is the proof as to why before we even solved for this answer, you had x from here, from this line here. We can establish that you have x plus 20 is equal to 3x plus 2, which is where this angle plus this angle equals this angle. And that's the proof. And here's just a helpful sheet for finding out all the sum of the interior angles, exterior, and if you want to screenshot this, use this for revision, anything like that. I thought it might have been helpful. So feel free to screenshot. And thank you for watching.